All right, we're going to get started on our last problem statement for this session, and then we have the very important Q&A. The Slido is working. I can see people's questions coming in. So if you go to slido.com, use the code Basecamp26, you'll be able to post questions for the Edwards room 5 and 6, which is this room here. If you can include the problem statement number as well, that's great. But if you don't, I'll work it out on my end. Right, it's a double act today. So we've had Anna for 2, and we've got Peter for 2 as well. So completing the brace of problem statements, Peter Lang, back to the stage, please. Thank you.
Thank you, Dan. What shall I say? Perhaps I could invite somebody else to come and talk. Right. Good afternoon, everybody, and welcome to my second problem statement. I'm Peter Lang from UK Power Networks, and UK Power Networks, for those of you who've just walked through the door, looks after the electricity companies, the electricity networks for London, the South East and the East of England. And the problem statement I'm presenting today is about the condition monitoring of surge arrestors. And your first question is, well, what's a surge arrestor? A surge arrestor, and this is just an extract from our network diagram. Yes, I do have some pictures as well, so don't panic. A surge arrestor is at the interface between the overhead line and the underground cable, and it's there to protect the underground cable, such that if we do have a lightning strike, the surge arrestor, instead of acting as an insulator, arrests that lightning surge and passes it down to earth, so that voltage, the overvoltage that has been caused by the lightning, doesn't appear on the underground cable, causing the insulation to fail. It's so much easier to do a repair on an overhead line than it is about having to dig up that the underground cable where the insulation perhaps has failed. So these surge arrestors are all as it says there, they're all about managing the overvoltages. Size of the problem, you can see now I've got there 13,000 instances, but they are constantly being changed, and the problem we've got is, and just to show you with the picture, what look like insulators coming out horizontally from the crucifix frame, they are the surge diverters. So you've got the cable termination coming up from below, and in this case you have a heat shrink termination, and then the overhead line is connected via the jumpers, and it will be then going on to another location. The bit of barbed wire on the left of the picture is there to be ignored because that's the anti-climbing guard, such that we could take the picture. So the question is, what's the condition of those insulators? And obviously, if you're working on the network under a permit to work, that network has been made dead. It's been isolated. It's been earthed. So it's not energized. So it's not going to be a problem. But a lot of the time now, we are incentivized to work on our networks using live line techniques. So you can imagine the live line engineers or the linesmen, they've shrouded up the conductors, they've got insulated gloves which are really quite thick, so you haven't got an awful lot of dexterity. But if you don't know what the condition of those insulators is like, how long do you want to be there for? It's a bit like the previous statement about the hazard zones, but this one is more distributed across the whole distribution network. Anywhere where we're working with our live line working? No, we install new switches live line. We install transformers live line. We reconnect the network. No, if a fault's occurred and you've got a broken set of jumpers, we've got techniques which allow us to join the two, a portable switch where you join the two conductors together. So you've already re-energized the circuit, allowing you then to make that electrical connection without having to be picking up any more load. But do you want to be anywhere near it if you've got a surge arrestor, which is, you don't know the condition of those assets? So our expectations are all about, and this is another example where you've got the overhead line, but instead of being, I know it's not very clear because this is the difficulty of taking photographs from the ground. When you've got a white sky, all you get is a silhouette. But what we're looking at, again, is we've got a cable termination coming up the left-hand pole of this H-pole construction. And the surge arrestors are what look like insulators coming off the crucifix, supporting the cable termination in place such that the jumpers can then go straight up onto the overhead line, but also jump around to the transformer, providing supplies to our customers. And that is the challenge. How do you apply a test voltage whilst you've still got your customers on supply? We don't get in prizes for having switching off customers. Customers don't like it. It's all about how much work can we really do safely using live line techniques. So what I'm asking you today is, let me just check, is there anything else I wanted to say? So one of the things that we can't do, we can't apply a higher voltage to the surge arrestors, because if you're doing that, you're going to be that's going to have an impact on the voltage supplying our customers. And we want it in such a way that you arrive on site, you do some tests, you reassure yourself that yes, this asset is behaving the way I expect it to, and allows to proceed to do whatever work that team has been set out to do. And in this situation, it could be reconnecting a new transformer. So there are a number of techniques of working with working live line. As you can see, the whole situation, this is outdoor equipment. So we don't want some laboratory-based sensitive equipment. It's got to be robust. Linesmen are not gentle with their test equipment. Linesmen will have they will have their van, and it will be stacked full of all the equipment that they need. So whatever solution we get, and let's get into the solution, or perhaps not. So what we're looking for is something that's going to be robust. And I think this is the biggest problem with problem statements is I've got a whole lot of different potential ideas, but I don't want to influence that gem that somebody in the audience is going to say, I've got an idea which we can fix that particular. I don't want to influence your thoughts. No, you may have a technique that we just haven't really thought about, and it's all about trying to find a solution. And I invite you to come and join us again in May, stealing Dan's thunder. Please, we're going to start that question and answer session. If you've got any questions, if I haven't made myself clear, please ask the questions. And again, just for completeness, I'm Peter Lang, and involved in all the innovation projects. I work in our incubator, so I'm a bit like the gatekeeper. No. If you've got an idea, as long as I can see the benefit, it will get passed on to our review panel. So, enough from me, and let's start that question and answer session.